so we move to the number 4 of the this algebra and the symbolic math with SymPy chapter. This chapter is we will use the knowledge we learned from first 3 parts to do the plotting. This plotting is used built in the class or the functions that SymPy library provided. So let's see the content. So it's simple. If you want to do the plotting, you should use this SymPy.plotting, this area, and import plot. And then we can use this plot to either plotting the one single expression or the multiple expression as well as the functions. So let's practice that all together. So I put this here. So in chapter 2, we learn how to make a graph with using this matplotlib. Now we use this SymPy the parts, and let's see. So here, so we just try to type in this immediately. So from SymPy plotting, so and we import the plot. Now we have this plot. So if you have that, you can see the empty one is already can give you a 3-dimensional figure of the charts. So here is the x, here is the fx, and here is the another dimension. So that is the empty one. And you can see here the object is SymPy.plotting.plot.plot. So it's our empty plotting, but it's already have our object defined. So let's make our the expression. So first, let's make the SymPy import single symbol. Then we define symbol x. And we can plot, maybe so we see express equal to 2 times x plus 3. So we use this formula, this variable. So now it's let's plot. So you can imagine this 2x plus 3 is our line with this slope is the 2, and then the shift up to 3 in y axis. So let's see here. So you can see from here. Let's make that. So here is the 3. So is this line and shift from the origin to the y direction, the positive 1 shift 3, the unit. So then x, this horizontal axis is by default is x, and this vertical axis y is by default is the function x. So that is the same as what we call that in the mathematical way. So you can close that. So this is the simple way that we can build this the plot. So like this one. So the graph showed that our default range of x value was automatically choose -10 to +10. So we can examine here. So they don't draw too long. They just the -10 to +10. You may notice that the graph window looks very similar to what we have done in the earlier chapter. It's because of this kind of the SymPy actually in the backend use matplotlib. So that's the logic is the same. And also notice we didn't have to call the show. So we just use the plot. They also in the behind this SymPy's plot is already make that show. And now let's see that you want to limit the value of x. So we can now do some more arguments transfer. So expression Then we give another is use our tuple. Looks like it's x, comma is -5, +5. Then you can see now is the -5 to +5. So that is the way or the syntax that we can use for our single line. And if we change the expression, express to 2.x.x plus 4x minus 9. So then that should be our the curve. So let's do here. So you can see now is our this we call this this powered 2 the lines. So if we see here, so if we put that is negative, then the direction is changed to the vice versa. So it's like this way. So that is the easier is whenever you have our this the expression. So then it can draw that for you. But let's see if we don't have our the real number x the result. So what this means. So you can see it's still can give this, but there's no result because it's not reach this x. So there's not coming to x's. They have those the imaginary, or we can say it's a complex number the solution. You can use other keywords arguments in the plot function, such as title. So now it's empty. So if we want to, let's back to here. So let's make some more. So title is a small case. So equal to our curve and x label just equal to the self variable and the y label equal to result. So let's make those. So a curve, self variable, and here is the result. So it's not definitely, so we can adjust those to make that optimize. But for now, that just gave you is are quite simpler compared to the matplotlib, because within matplotlib is we need this, the different configurations one by one to set those title, x label, y label. So, but now it's you can using the this terminal or the command is just one line command. You can make this drawing. So like this way. So and then let's see here. Next is the plot show in this one has a title and a label. You can specify a number of other keywords arguments to plot function. So the show false, like is like to customize the behavior. The show keywords arguments shall allow us to specify whether we want the graph to be displayed. Parsing show false will cause the graph to not be displayed when you call the plot. So let's see here. So if I put this show equal to false, then it just create this plot, the object, but not show that. So if you don't have that, then default value is true. So then that is the one. And we can also save that is p. Once we make this, so you can assign that to the p, or you can see here. So let's save. So now is I'm in the root. So save the 0402. plot.png. So So I create this, and let's see whether that is also saved. Yeah, that's perfect. It's this one. So let me paste this to our the chapter folder. So that means it's quite nice. It's just one line. We can save that. Definitely, you can use p dots as a variable to send this object to p first and without show. So if we have that, we don't mention show to false. Let's see what will happen. You see, the first is you show this, then you assign that to p, is show that again. So when you make that to assign to our variable, is better is you have this show equal to false. So that is just do the assignment, not do this the plotting show. So let's do this first part, the more the exercise, plotting expression inputs by user. So now is we have putting this in command. Let's do this. If we see here, expression is input is by the enter R expression. Yeah, it's, from the grammar is I should use n, so but it's fine. So let's put that is 2 dot x dot x dot x. Let's put that in the longer. So minus 6 x plus 8. So that is the expression. So but keep in mind is this is the string. So you cannot directly use that. So if you make a plot express, you will get, oh, that is the, let's see, so let me see, express is this one. Why I have two charts? Oh, that is the interesting is I don't use this simplify, but looks like it's a plot is already make this adjustment on this part is I haven't convert that, but normally is I should do this from SymPy import simplify. Then this we make this express 1 equal to simplify express. Then you can compare is express 1 is our actual expression, and x is the symbol. Now is I plot express 1. I got this. But the interesting thing is even I don't do this simplify. So I think is for this plot they already have more powerful the ways that they can directly read our string inputs and also interpret this as our expression. And what if is if our we have expression with two variables like 2x plus 3y minus 6. The solve function will help us to make this expression. So let's see, and then is we can starting to do the this plotting. So let me see is express. Assume is user input this 2x plus 3y minus 6. So the reason is error is I haven't assigned or defined y as a symbol. So y equal to symbol y. Now this is allowed. So express is this one. So now we can do the solve. Express y. So y is this one. So we haven't import solve. So whenever you got error, don't be afraid. It's just read the error message. So SymPy import solve. Now this is okay. So means y is equal to 2 minus 2x divided by 3. So it's the same as this one. So now is we have this solve, and we assign this solution variable with this solve result. Then we can see expression. So let's make this demo. So solutions equal to solve express y. Yeah, so actually, so we don't need this, let's see. So if I use the code solutions, it's the same. So that is, I can use this variable y, or I can directly use this symbol y. So then express y is the solution 0. So is this is equal to solution 0. Express y, so solution is not solutions. Now let's see express y is getting those actual the element. So now is we create a label solution to refer to the result returned by the solve, because the solve the return value is a list. So you need to get this index number and to retrieve from the list of the actual result. So we can call this plot function then to make this expression. So plot is expression y. Now we got this line. So that is the thing is if we have a user input or expression, then we can do this plotting. So let's try this program altogether. So let's see. So 04025 is our plotting expression .py. So let's make this purpose load the graph of an input expression by user. So yeah, try as I mentioned many times, is try to make this kind of the typing by your own. Do not try to copy paste. So from typing is we can think and we can evaluate whether our knowledge is really internalized. So what we will do is let's do this one by one. So SymPy, so we need to import. So first is definitely we need to import a symbol. So we need to define the symbols. So let's make the symbol. But what I have tried is this simplify looks not like is we can keep this simplify out, and it still can be explained by the plot. But since it's, we need to do this the calculation, so all the solutions we need to use this simplify. So. And then we need to use solve to find the solution. And we also have our plot. Plot is not directly in SymPy, it's under the plotting. So import the plot. So when you try to type, time after time is you may start to give yourself a remember. So let's also starting from our primary the code is these are the standard header. Then what we want to do is we need to define is one expression from the input. So input is please enter one expression. with x and y. So we have two the variable expression. Then we use try except. So try if I do this simplify. If the simplify has arrow, then is we get those catch these arrows. So except simplify arrow. I think it's we need to also import this simplify. So here I think it's the author doesn't make that. So let's see. So invalid inputs. And if there's no arrow, what we will use else. So that is the passing this validation. Then we will do our plotting. We will make this function. So transfer the argument express. Yeah, and let's do this. So here is the simplify. Is have the issue. So let's back to see the simplify where we learned this catching. So it's here. So you can see it's, if you want to use the simplify arrow, we should have this SymPy call simplify import this arrow. Otherwise, it's, they are not be able to run. So simplify dot call dot simplify import simplify arrow. So this one now this is recognized. So please bear in mind this here maybe are missing one line by author. So we don't have that, but we add by our own. So that is one I want to highlight. And then let's do this definition. So plot expression with the input the arguments. Now let's see. So maybe we see the return now. Then let's make this program is okay. So let's run first to, so let's quit Python and let me run. So it's ask you give our variable expression. I just make maybe it's I use 2y. So to see invalid value inputs. So that means this catch except is working. And if I make our the valid, so x plus y minus 1, I got nothing because I haven't run the put contents here. So what we want to do is we have our expression, and we already use simplify to make that as our actual expression, convert from string to our expression. Then what we will do is we will have that, I think it's, we also need to define x. So solve y. So let's see. So if I input x, what's that the arrows? Because we only define y is not enough, I think. Symbol y. And then we put these solutions equal to solve express dot y, comma y. So express y is using the solutions the first index, then is express y. So we don't need return anymore. So let's run this. I gave also our x plus y minus 1. That is interesting is I don't need to define x. So that is the part. So if I don't define y, so what's that happened? Here is y is not defined. So but x I haven't defined. So that is the interesting. So print. So let's see the express. let me print express. So try to trigger is they do this printing with X. I think it can be printed. So it's our simplify. So but it's I have some question is because I haven't do the this X the definition. So maybe is I put this as the X. So expression, so including X and Y. So if I do this, now I got this X is not defined, but if I define X, and then do this X plus I got this plotting. So this one is I have the open question because our target is we want to have Y as the solution. So here maybe is question. No need the X definition as a symbol. It's working. So that is I think is our interesting parts I would like to talk. Okay, let's continue for the second one. So we finished this first one already. Then this let's plot multiple function in one the chart. This one is we haven't tried in earlier the matplot lib, but let's see how we can do this in this the SymPy plot. So we can try from the Python the terminal directly. So let's back to the terminal, and then from SymPy dot plotting import plot. And then we define those symbol, and then we make our symbol, and express 1 is 2x plus 3, express 2 is 3x minus 4 maybe. So let's just do this, and then we can see so plot express 1 express 2. So we just use a comma to separate them. Now you have two lines, and by default they have a different color. But now definitely we still missing something. We don't have the legend, so we don't know which line is which one. So, but that is not the colors. The actual things the difficult for us. So let's see here. We do this two-line plotting. So let's create this as our program. So 0402.6 two-line plotting.py. So let's quit from Python, then purpose, draw two lines in one plot. Don't fill such kind of header. Well, even we only have 3-line header, this don't feel that like it's time consuming. It's try to be familiar is be used to write down those comments. So that will be useful for later on of your code review. So first let's do this SymPy plotting import the plot, then this from SymPy, import the symbol. We only have for one single symbol, or not symbols. Oh. Just leave that. I don't know why they have keep the autocorrect. So X is the symbol X. Yeah, the intro is a small x. Then is a P. We put that is plot 2 times x plus 3. 3 times, maybe we put that is 4 times x plus 1. And we have is a legend. So legend is true, then that's give the legend. Since we assign this to a variable, we learn this, we can make that show to false first. Then we can start to use show. So then we have a p0 dot line. We give a color. Line color is equal to b is the black. p1 line color is equal to red. So let's comment this first to see the default color first, then p.show. Let's run this. So we have these 2 lines, and very smart is they give you this the legend. So the orange line is the second the expression. But what if we put this color explicitly defined? Then you have our black p0. Let's see. So p0 line. So let's have a look. Yeah, it's defined. So now you have this blue line, the red line. So it's quite the simple with this single character to define the color. So line color with this underscore divided. So now we have this one. So my legend is showing here. So you can see it's. Let me see. Run this again. It's possible is because my right line is already reached this area, so they have this the best position. So let's leave that. So those one is we have already learned until now. They finished this subchapter. So just be aware is I leave this code for your references. P0 is actually the first line. So that is you can treat this as with the sequence. So this is the index 0. This expression is the index 1. So then you can use this to identify the line or the expression and give some more configuration settings. So that is the ways you can make some adjustment and putting the more and more the expression into one the chart. So if I put, for example, I made the x minus 5. So I put this, and if I don't give our color, so just run. So I have 3 lines. So you can see here. So by default, is assigned some different colors by the SymPy itself. So you can try to keep adding those multiple expressions, then you can see what was the difference. So maybe I put this to x. Then I have a curve, so to make those multiple lines comparison. So we have other the powerful plotting tools, like there's a tool is called the GeoBar. So that can also draw some interactive chart, but using SymPy, you can see you already be able to draw some mathematical expressions by your own. So that is the until now we have finished the knowledge parts. We learned the basic symbolic math using SymPy. We learned how to declare symbol or symbols altogether, constructing the expression, and then is we make the solving, make the plotting. So I hope is you get those knowledge yourself, and we have enough weapons on hand. Then from next video, we're starting to do the challenge for this chapter. So see you next video. Bye for now.